Okay, so I actually thought I had started the recording. Now I am. What I had mentioned prior to this is I have a handful of US self-data data too. You should get it over the next couple of days. For those of you that don't have it, there's still a large part of the projects you can work on, right? So the introduction, the lit review, the economic principles at play. You can even start to write about the data. So even though I haven't gotten it to you, even thinking about the variables that you're likely going to have, or at least what your maybe y or dependent variable is, you can get a pretty good start in the paper. But like I said, most everyone should have their data by the end of the day, Thursday at the latest. I'm hoping I can get it out by the end of the day, Wednesday, but Thursday at the latest. So we're gonna go through about 4 papers this week. I'll put up a weekly reading after class today, so we'll go over a few papers today, but the weekly reading won't be up until after this tape lecture is posted. It's gonna be a shorter lecture today. I also want to do a little bit of review of some of the things maybe that we had talked about with discrimination in the labor market, kind of combining multiple things, and just think about how we can draw these shifts, right? Or draw these changes. Most of them will cause shifts. So um, we're going over a couple papers today. It's somewhat related, I would say, to gambling. Uh, I think the first one maybe you could argue is a little bit less gambling than the others, but it's going to give us a lot of good examples of how we start to interpret coefficients. So on the final exam, right, some of the potential questions I could ask, because we've covered so many different types of papers now, and hopefully by the time you're done working on your project, we have a pretty good understanding of how we interpret coefficients. Okay. Now on the exam, I'd make them more simplistic probably than some of the papers that we're looking at. Um, but we'll get a lot of practice at interpreting things today. So fantasy sports in the U.S. and Canada alone, and these are somewhat dated. I think these are like 2017-18 numbers. 57.4 million players. Average annual expenditures of almost $200, and then people that play every day, we're talking about 320. So this is data is kind of from like things like DraftKings or what's the other one, FanDuel, which have now been legalized. I haven't seen the numbers because they've been legalized. In fact, that would be, if we could get our hands on that data, it'd be really interesting to look at. So in 2015, they had to report 2.6 billion in entry fees alone, right? So we're talking a ton of money, right? So these companies paid out over a billion, but they kept 1.6. So they're making a good chunk of money. So with this, increase in fantasy sports activity, where there's now, it used to be that there wasn't as much money on the line. Now there's this daily play that you can do. What is the impact we could potentially see on sports, right? So if at all you're, attracting anyone from outside of your typical sports viewer that then starts to play fantasy, and then after they start to play fantasy sports because they like gambling, start to watch more games. Potentially, these are like complementary, right? As the demand for this one good has gone up, the demand for the other one is increased as well. So people are kind of made aware. It's almost like marketing, right? I got into fantasy sports, and then I realized how much I like watching these games when I'm invested. Or even for people that were current viewers, right? You can think about what has this done when it comes to a choice between, even watching a game and doing anything else. So we looked at this as going to the game, or attending the game, or watching the game. But you can think about the same scenario. Like, let's say I'm choosing between two things to do with my hour of time, right? And so I've got kind of the marginal utility, and then over the price of whatever watching the game is, and maybe the price is simply the opportunity cost, right? What I'm giving up with an hour of time, but also kind of maybe for like watching on TV, it incorporates NFL package, or this price could be implicit and explicit. And so we're gonna watch the game as long as it's greater than the margin utility of, say, I don't know, like, let's say like it's a Sunday night or whenever this is, and Dancing with the Stars is on, right? And so maybe prices are similar here, right? It's the same cost of time, and so it could just be the margin utilities that we're comparing. But if playing fantasy sports, right, can increase this margin utility at all, right? If I play fantasy sports, I have like more of an interest in watching the game. If it drives up this margin utility, it could go from before where maybe this was the case, as this gets higher, it's more likely that the person then, the margin utility per dollar is higher for watching the NFL game, and so they switch over, right? So I wrote watch here. I should have, let's say, watch the NFL game, right? Or whatever it is, right? It could be fantasy baseball or fantasy basketball. But this is what we're thinking about is going on, potentially, is that we're making it so that the utility derived from watching the game is now higher because these individuals are playing fantasy sports. And you kind of think about, what's the change in that margin utility from a change in the amount of fantasy football I consume. We assume that's positive. The more fantasy football someone plays, the higher the margin utility of watching that sporting event, increases by. So if that margin utility increases from watching that game, right, demand to maybe even attend the game, so even if it's not just to watch the game on TV, where I now would be more likely to pay a higher price for the NFL package, or if it's for tickets, I'd be more likely to pay a higher price for this tickets, right? All of that demand increase is going to drive up revenues for the sport. Now, this is the theoretical thing. So the question is, does a greater number of fantasy sports participants, would it increase the attendance we see at that sport? Maybe does it increase ticket prices? Does it increase TV viewership? All of these things we could look at, but the real one we're going to focus on here is just attendance, right? That was one of the measures that they had in the data for this paper we're going to talk about. Okay, so Ball State's very own Professor Nesbitt wrote a paper in 2010 and found that NFL attendance and then consequently, excuse me, MLB and NFL television viewership increased with higher numbers of fantasy sports participants. So I don't believe, here we go. That's what I'm using. So however, okay, perhaps because doesn't account for the fact that a lot of NFL games sell out, so our attendance measure can't really go up. So we might get like a lot of zeros there. It could be that this is actually understating what the total effect could be if we in fact had higher capacities, or maybe we don't have capacity or attendance, but we have ticket prices paid, right? That would help us understand, see if there is a larger effect as well. But with just attendance, we can get some measure of it. So the regression they run, right? Their dependent or Y variable, they actually had not attendance at these different stadiums, but they had whether or not an individual attended a game in that year, right? So it was whether or not they attended any game that year, and they could break this down to they attended an NFL game or did they play an MLB game. So this one is set up in the context of Major League Baseball. So there was this survey put out by ESPN, and so they asked individuals, did you attend a game in the previous year? Would you describe yourself as an avid fan? Would you describe yourself as a Major League Baseball fantasy player? And then demographics, household variable, whatever these other things are, right? And so the hope is that, well, we're going to control for things like, was this person just a fan of baseball? There are different demographics, maybe even including kind of some socioeconomic classes of where their income falls. They're not a specific amount, but these large categories. And then here's our coefficient of interest, beta 2. Because MLB fantasy is just whether or not they play fantasy sports or not in Major League Baseball. It's a 1 if they do, 0 if they don't. So a 1 unit increase in this variable is just going from a 0 to a 1. So going from not playing fantasy baseball to playing fantasy baseball online. With that 1 unit increase, the change in whether or not someone attended a game in the previous year would go up by beta 2. So this is where we said if we have a Y or a dependent variable that's a 1, 0, then the interpretation, yes, it's the increase in our Y variable, but it can be even more so interpreted as it's an increase in the probability that Y variable becomes a 1. Or, said differently, beta 2 is an increase in the probability that I attended a game in the following year that comes from playing fantasy sports, right? So this is, we have a 0, 1 independent variable, a 0, 1 dependent variable, and so the interpretation starts to become a little bit, I think it's a little bit easier, because a 1 unit increase in our X variable is just going from not playing to playing fantasy sports. And beta 2 is now an increase in the probability of our y variable happening, right? Going from not attending to attending. Okay. So what do they find? So this is the variable of interest, right? This, oops, I clicked on it. Whether or not they played fantasy sports, right? And so here's our coefficient estimate. Here's our standard error, and for whatever reason they decided to put the stars on the standard errors instead of the coefficients here. But still, 3 stars means this is statistically significant, and that means statistically significantly different from 0, right? At the 99% level, 2 stars is different from 0 at the 95, and 1 star is different at the 90%. Right? So they do something that's a little bit kind of different with this 2-stage probit, but just to kind of show, no matter which way we do it. And probit, all that means is we had this y variable that was 0, 1. But if we kind of look at, this is the one that we're going to focus on, that kind of we understand for our class. This is a more complicated econometric strategy that we haven't talked about. Maybe in 330 you might go through something like 2-stage. So we've got MLB, sorry, I said Econ 330. I meant in econometrics, which I think is 430. I can't remember the exact number. So if they played fantasy baseball, it looks like how much more likely were they to attend a game in the next month? An increase by 0.4, which would actually be an increase in the probability of what, 41%? So a pretty large increase. These are pretty significantly large increases. Pretty strong effect that's coming from there, and significant at the 99% level. Right? So we can kind of walk through these other things. Some of these are interesting. So if notice if the team in that area that the person lives in, I think they define this as like the nearest team. If the win percentage of the home team was 0.00 or was 1% higher, it only increased the probability by 0.4%, so not very much. Notice if I have lower income levels, it predicts I'm less likely to attend a game. Higher income levels, I'm more likely to attend a game. That kind of makes sense, right? If the ticket price is higher, right? If the ticket price goes up by $1, I'm 0.8% less likely to attend the game. So this kind of shows our relationship between price and quantity, right? Demand. That's kind of a nice picture of that. You kind of see male has positive, you're more likely to attend if you're a male a Major League Baseball game. And there's all these other controls for education and things like that. Some of this is interesting. Even controlling for income, if you have a higher education level, you're more likely to attend a Major League Baseball game. So we can kind of walk this, even the 2-stage, which like I said, I won't kind of describe in detail the econometric approach, but they predict your likelihood of playing fantasy baseball and seeing the effect of that. So here we still have this strong positive effect. These coefficients are interpreted a little bit different, but pretty interesting, right? So if we kind of break this down into marginal effects, so this 2-stage probit, they break it down to marginal effects because you can't really interpret this. If I'm not, so there's these kind of different combinations we could look at, right? What are the effects of playing Major League Fantasy Baseball if I'm an avid fan, and what would the predicted probability I attend if I'm not, right? And all the different combinations. So notice if I don't play fantasy baseball and I'm not an avid fan, there's about a 42% chance I purchase a ticket. If I was an avid fan and I played, there's about a 70% chance. So what's the marginal impact of being an avid fan? Well, for someone who doesn't play fantasy baseball, the impact was about 28%, right? So for these non-avid, going from if I never play fantasy baseball, if I go to being not an avid fan to an avid fan, much, pretty big increase. The one that's more interesting is if I go from not being, right here, I'm not an avid fan, and I don't play, there's only a 42% chance that I buy. But if I am not an avid fan, and I begin to play fantasy baseball, it increases to 83%, which is a marginal effect of about 40%. So being an avid fan only had an increase in the probability I bought a ticket by about 28%. But not being an avid fan and playing fantasy baseball increased that probability I purchased a ticket by 40%, right? Or nearly, actually, if we think about it this way, almost doubled the likelihood that I purchased a ticket. And then if I was an avid fan playing fantasy baseball, it still increased the likelihood that I bought a ticket by only by about 24%. And same thing, if I played fantasy baseball and I went from not being an avid fan to being an avid fan, it only increased my probability of purchasing a ticket by about 12%. Right? So this is I don't know. I think it's interesting, um, an interesting result that shows fantasy sports are potentially driving up the demand curve for individuals to not only like to watch the game more, but here to even attend the game, right? Purchase tickets and to go to the game. Okay. Oh, why do I have just a random question there? Oh, yeah, I know why. So we'll skip that slide. I'm not sure why that ended up in there. So the next thing that we're going to talk about is kind of betting lines in sports gambling. Okay. And actually, I want to double check something since I don't have a lot of people live here. But if I have anyone, I want to double check. I got this up here because now that I think about it, I may not have. So if I didn't, I did not. Let me go here. Oh, it's already open. Let's go to save this Adobe as well, because sometimes it doesn't go over. I apologize for this little delay. But for those of you, any of you who have signed in live, I'm surprised I haven't gotten a question yet about where the slides are. And it just kind of dawned on me as we were going through them. So let's go to 3:30. Select these two, drag these over. All right. So those are getting posted. So now we can kind of go back to the slides and you can open those up and follow along. So where do we leave off? Right here, where I have that slide that shouldn't be in there. So the next thing that we're going to talk about is kind of another paper, some more regression results, which start to look at betting lines in gambling. Right? So we'll kind of walk through these. Betting lines are set, you know, if we're talking about betting lines in sports gambling, the ones that I'm specifically going to be talking about are when we look at over-unders. So this is specifically the number of points that a team is favored to win by. There's all other types of things you can gamble on, but we're going to focus on these for one reason specifically, because it allows us to understand some pretty interesting individual betting behaviors. Okay, so betting lines are set so that we can predict how many points a team is favored to win by. So think about the home team. The betting line was 20. That means the home team is, the over/under would be if they win by more than 20, and you put money that they cover the spread or have the over, then you win. If they didn't win by more than 20, then you would lose. So if they won by 19 or less, and if they win by exactly 20, it's kind of a push, and you get your money back. Okay, so the way these betting lines are set, the way they choose this value of 20, right, is that should be what makes this a 50-50 bet. So controlling for all the factors, putting all the information they have about the team's quality, maybe potentially players that who are injured for the game, the weather, how well the teams perform in the weather, or different types of weather or stadiums, all that should be factored into how this number was chosen, and it should be that number makes it a 50% likelihood that a team covers, wins by more than 20 points, and a 50% chance they don't win. They win by less than 20. You can kind of think about this as well. If it doesn't make sense because the push is there too. The 50-50 bet, you can kind of think about it conditional on that a push doesn't happen. There's a 50% chance the team either wins by more than 20 or a 50% chance they win by less than 20. Okay? So what should be the case is then, if these really are 50-50 bets, when we look at the actual bets placed, like if we go to any company who takes these sports bets, it should be that 50% of people are voting for a team to cover the spread, and 50% are voting that they don't, or betting that they don't, right? So do individuals bet close to this 50-50 split, right? Well, before we actually look at the results of how people are betting, let's just look at whether or not these are being set correctly, right? If the betting lines are set correctly, then it should be that about 50% of the time the teams cover and 50% of the times they don't. So let's first just focus on whenever they set a betting line that's more than 7 points. Right? So if they set this to be more than 7 points, in any given year or kind of collection of years, it looks like it's a little above or a little below, but if we look at the average here, it is right around 50%, right? Right around 50% of the games in which there's a 7 point spread or more, 50% of the time, the underdog is covering. The underdog's not covering. The underdog ends up kind of ruining it, right, or kind of winning. So if the spread was 20 points, the underdog ends up maybe not winning the game, but at least being within 20 points of the other person, right? So it looks like they're setting those pretty well, right? It's about 50% chance because there should be a 50% of the time the underdog team, you know, covers that spread, and 50% of the time the home team covers it. So if we then break it down though to look at these betting lines set at 28 points or more, well, now if you look at the winning percent of the underdog, notice, with the exception of this one kind of 4 year time period, much, much higher, right? Much, much higher percent likelihood that the home team or the favored team doesn't actually cover the spread, right? The underdog, right, is actually kind of breaking that or covering that spread about 50. If we check the average here, it looks like it's 54% of the time. And so it looks on its face that whoever's setting these, the companies and people setting these betting lines are doing a pretty good job for closer games, but the games in which they're setting these really, really high point differentials, they're probably being a little bit, yeah, how do I say, they shouldn't be setting at 28. They should be setting it probably at something closer to like 24, 25, right? They're getting a little ahead of themselves and setting this a little bit higher than they actually should be. Because if they set it at 24, well then maybe the underdog doesn't win 56% of the time. Maybe it falls to that 50%. So if you know this, well now I know that, okay, betting lines should be a 50-50 bet, but whenever I see betting lines that are a high number of points, I have evidence here that says, well, they're not good at setting those. When it is going to be a kind of a blowout, they never know exactly how large the blowout will be. Okay? So if I'm betting and I look at that and I know it's a 50-50 bet, it makes more sense to always bet that the underdog is going to win in these games where the spread is really high. Right? Here it's kind of a crapshoot. Right? It's about a 50-50 shot if the game is the betting line is something lower than that, right? 7 points or 10 or 14. So if we look at how do people actually vote, right? This was the actual performance of the teams. How do people actually, I said vote again, how do people actually bet, right? So for those games where there's just a 7 point or more differential, notice people tend to, there's a couple years where they're a little bit higher. It looks like maybe they're not quite betting in line with what the actual performance is, right? Notice the actual likelihood the underdog covers that spread is right around 50%, and it looks like here the average is 52-ish percent. Kind of interesting. I've never seen someone do like a year by year analysis, but notice this percent is kind of increasing here over time, which is interesting. But then if we look at those blowout games, right? So yes, the underdog is more likely to cover that spread, but look at how people are actually betting. We have 73, 59, 57, 64, much, much higher percent. And so even though, yes, it is more likely the underdog kind of covers that spread so that they don't lose by more than 28 points, right? It is more likely that they'll cover it, not near the likelihood of 70%. So we have individual betting behaviors that are inconsistent with what the actual results are. So yes, you should be more likely to bet that the underdog kind of covers that spread, but not this much more likely, right? So we see some betting behavior that doesn't really kind of fall in line with what the actual probabilities of those teams covering the spread or not are. Okay? So they're not setting them, those betting lines correct, but people are also betting on them incorrectly. Okay? So with this idea of kind of covering the spread, um, we can think about, once again, if we're thinking about the team that's favored, whatever that betting line is set at, that's how many points that, if you think they're going to win by that many points or more. So 50% chance they cover the spread or win by more than what that line's set at. 50% chance they don't, or they win by less than. Or if it was a negative, like it was a negative 20, that means that there's a 50% chance that you're saying that they'd lose by more than 20 or lose by less than 20. But I think the positive one's a little bit easier to kind of talk about in terms of English. And I already mentioned this, because there's a push, we can think about it as conditional on a push doesn't occur, there's a 50% chance that they hit the over or under. So if a team kind of covers for the previous spread, so let's say that a team was favored in the last 4 games, right? And maybe each game, we'll just keep it simple, they were favored by 10 points. If they won each one of those games by more than 10 points, we'd say they covered the spread in 4 consecutive games. But the thing is, betting lines are set every single week, and they should factor in all the information so that they really should be independent. Every week, the bet should be 50% likelihood they cover or they don't again. So if we have these things that are occurring, these number of trials, and they're all independent, this goes back to what we talked about in some other context of the hot hand, right? If the underlying probability hasn't changed across any of these different weeks, right, the betting line should always be 50-50, 50-50, regardless of what happened in the past. They should be factoring that in, so it's always a 50-50 bet. Then it shouldn't be that if we see a team cover the spread 4 times in a row, they're no more or less likely to cover it next week, right? There's still a 50% chance they do, unless they're not independent, right? So that's as long as they remain independent. Now, it could be that whoever's setting the betting lines are kind of underrating how good a team is 5 weeks in a row. But, for now, we'll assume it's kind of independent and see if there's some of this hot hand. So, our sports bettor is more likely to bet a team covers the spread if they've done so in the previous week or in the previous weeks. Okay? So we'll go to that paper. I'll kind of walk you through this. I'll put this up on Canvas as well. So as we're walking through this, I didn't want you to think this was the reading for the week. I think I actually had it labeled wrong. So let's go to, here we go. Hot hand betting. Oh, try again. Oh, because it's open. Just close this. All right, there we go. And then we'll get this up on Canvas. Okay. Maybe. I thought I dragged it over. Oh, there it is. So hot hand betting. And we'll actually look at the paper. So we'll open it up. All right, so there's a couple things I want to focus on here. So really their question is whether or not if a team covers the spread a higher number of weeks in a row, are they more likely than to bet that they'll cover the following week? And for different streaks, so if they covered the previous 1 week, previous 2, 3, 4. Right? So let's see, they've got a nice kind of outline of what their regression they're going to run is. So they have this betting data, and they can look at the percent of people that bet on the home team. So this goes from 0 to 10, 0 to 100, and we should see that whatever the home team is, whatever they're favored by, the percent of people that bet to cover that spread should be 50%, right? But it may vary a little bit from that, and we want to know how much does it change when I've got kind of these different controls. So is it a road favorite? Is it a closing point spread? But here's the real one I want to focus on. What's their kind of covering the spread win streak, right? So kind of come down here. I'll look at that first table. Here we go. So I'll rotate this. So if we just look at means, we haven't run a regression yet, but notice if teams are on a shorter winning streak, and when I say winning streak here, it's a win streak against the spread. So it may not be that they've won the last 4 games, but if you would have bet on them to cover the spread the last 4 games, they covered it, right? So even if they were the betting line was -7, right? They were going to lose by 7 points. They at least lost by less than 7 points, right? So that would have been them winning against the spread. So if they've done that 1 week, 2 weeks, 3 weeks, 4 weeks, or 5 or more weeks in a row, notice the percent of people that vote on that team to win is right around. Looks like it's about 50%. A longer streak here, maybe it goes up a little bit. But when they have a losing streak, notice there's kind of, especially if 3 times in a row they don't cover the spread, there's a pretty big dip here, which is kind of interesting. So maybe there's something weird going on. But also, if you look at the percent of teams that, or sorry, the percent of people that just bet on the team, notice the longer the win streak length, that goes from 54 up to 60, 54 up to 62, and so there's kind of this increasing likelihood that people are betting on this team to kind of win against the spread if they have a long win streak, or not if they have like a losing streak. Right? But we can only get so much information from means, right? We want to control for other factors. You could also look at if they're on a short losing streak versus a win streak, similar kind of idea. Teams on a win streak, you start to see the increase that people bet on them to win starts to go up. Shorter losing streak, people start to bet less on that team. So let's go. We actually want to have to rotate this all the way around. So what we want to look at is a regression where, and what I think what they do differently. Let's see. I forget what the difference are between model 1 and 2. OLS equation 1 dependent variables percent of bets placed on home team. Yeah, usually it tells us in the footnotes. Oh, but it doesn't here. So let's see if we can find a description of what table 3 is. Okay. OLS parameter, the standard errors. Oh, they did something different with standard. So we don't need to worry. Winning and losing streak indicators. Model 2 contains winning. Okay. So we'll focus on model 1. So we've got what the point spread was, so we're controlling for what the difference in the game should have been, right? Maybe it's that when we saw teams cover the spread more weeks in a row, the point spread started to go down or go up, and so we're going to control for that. So we're comparing 2 otherwise equal games, 2 games where the point spread was exactly the same. We then control for whether or not the visiting team was favored to win, right? And so, 2 games where those are the same. And now we're just starting to play around with, okay, given that the point spread was exactly the same, and that the visiting team was favored both times or not, now if in one of those games the home team has a 1-game win streak against the spread, how much more likely is it that someone bets on them or what percent increases it on the bets that home team covers the spread, right? And then we have different streaks for wins and different strengths or different streak lengths for losses, right? And I guess the one that they left out here must have been a push, right? Because we have to leave out one category. We kind of talked about that last week in one of the papers. This has to be relative to what? Relative to no streaks, which would be a push in the previous week. Or I guess it could have been a 0. Yeah, no, it would have to be. So if we look at this, if I win 1 game or win against the spread 1 game back, then in the current game, it's more likely people bet on that team to also win against the spread. It's significant at the 90% level. Now 2 games doesn't look like it's much of a different effect, and it's not quite significant. But once we get to 3, people are even more likely to bet on that team to win or win against the spread. Very high significance level. 4 in a row, it's a pretty high effect. Now, why would it be that really long streaks, that effect goes away? Well, one issue is we don't have a lot of situations, like just a lot of observations where this occurs, but maybe it could be that people fall victim to the hot hand fallacy for short streaks, right? Where they think, oh, if they covered it last week, they're more likely to cover it this week, right? Well, no, the bet is still 50-50. But it could be that after a while, for really long streaks, maybe they start falling victim to the gambler's fallacy, which is that, oh, if they've covered the spread 5 weeks in a row, there's no way they cover it in the sixth week. So it's kind of interesting that it looks like there's some behavior here that maybe initially this increase looks like, okay, maybe there's this hot hand that occurs, but as the streak gets longer, we start to think and fall victim to that gambler's fallacy. I believe it's the same thing. I think if we look at losses, so if a team lost against the spread in the previous week, they're way less likely to actually, people are way less likely to bet that they cover the following week or that they win against the spread the next week. They're more likely to bet that they are going to lose against that spread again. They still have pretty sizable and pretty similar sizes in terms of if they didn't win or they lost against the spread the last 2 weeks or lost the last 3 weeks. Those are all similar effects, decreases in the likelihood that someone bets on them to then win against the spread. But as we get to these longer streaks of 4 and 5, once again, it could just be because we don't have as much data, but look, these start to become statistically insignificant or in a lot closer to 0 in magnitude. And even over here on model 2, they're actually positive. Now, statistically no different from 0, right? We don't have any statistical significance here. But, so it is interesting that maybe people aren't falling victim and having the gambler's fallacy here where, well, they've lost against the spread 5 weeks in a row, they have to win this week. But at least the hot hand effect kind of is going away. Right? Once again, it could be because we have very few observations where this occurs. So it looks like we have some evidence that the hot hand, people are betting kind of with a hot hand. This was specifically in the NFL. You could probably look at different leagues. I know there's a lot of basketball betting lines data that's out there. In fact, one person actually, I've given that to them for their project. But just another paper where we can start to look at interpreting coefficients. And then here, these are just 1-0, right? It was a 1 if they lost the previous 2 against the spread, 0 if not. 1 if they lost the previous 3, 0 if not. So this is all kind of a 1 unit increase, was just this going from 0 to 1. And here, if we want to think about what the change in the y variable is, remember it was measured in percent, just so it was like a 3%, 3.5% less. The decrease in the percent of people that place bets on the home team to win would be 3.5% lower, or 5.1% higher, right? Because our y variable is measured in percentages. Okay. So that's another paper. So I just wanted to go over a couple of those papers today. I think what we're going to do now is I just want to walk through a little bit to kind of get you, I guess, just some more review of how we do some stuff with the labor market. So building in a bunch of different things. So you probably have to follow a little bit along to what I'm saying. I'll try to kind of write some of the things down on the board. I'm kind of doing this off the top of my head. But I just think some more practice in how we look at some of these labor market questions. So let's start out and let's assume, right, that I have two kind of markets here. Two labor markets. It's really kind of can think about this as one, but I want to draw for two different players. So this is like player A, and we'll call this player B. So let's assume for a second they both have the exact same supply curve, right? They're willing to play the same kind of quantity of hours, right, or quality of labor hours at the same wages, right? So similar supply curves. But now let's assume player A is going to be better than, right, or has a higher quality than player B. Well, we know that the demand curve for labor is the marginal wins that come from adding that unit of labor times the marginal revenue per win. So if player A, I can get this here, let's say there's two teams. So we know that player A has a higher quality than player B, and we also know that he has a choice to go to two different teams. Okay, team A, right, you can kind of think about has a higher demand curve than team B, or the marginal revenue per win coming from team A is greater than the marginal revenue per win on team B. Kind of give you a close up there. Hopefully this. I get the webcam to kind of maybe. I'm going to switch back off and on real quick because I think sometimes there it goes. So we know that the marginal revenue per win is higher for team A. Like they're a large market as opposed to a small market. We can think about maybe team A as a large market. So just for player A, we can think about, all right, let's assume that both players were going to go to the same team. Okay. So here would be the demand curve for labor for player A if he went to team A. Right? And here's the demand curve for player B if he went to team A. Right? So why do we know this is the case? Well, for player B, we said he was of kind of lower quality, or the marginal wins per labor that came from player A was what less than that came from player B. So if they were both to go to the same team, who would that team A be willing to pay a higher wage to? I think about this is wage for player A on team A. This is the wage for player B on team A. Okay, so we can kind of see if they were both on the, going to go to the same team, player B would get a lower wage because he's of lower quality. Right? But now let's say, well, what would team B be willing to pay these players? I'm going to draw this with a different color. I'm going to drop my marker. So if team B is a small market team, lower marginal revenue per win, we know that the demand curve for labor then for the player A would be lower, and the demand curve here from team B for player B would also be lower. Right? So now kind of the wage for player B from team B, and then we'll call this, I'll erase this for now. Hopefully you can pause it and go back and see what was there. Would be the wage for, actually, sorry, player A, team B. Okay. All right. So we can kind of see if they both went to the same team, right, red, well then the wage for player A should be higher than for player B. If they're both on team A, wage for player A should be higher than player B. Okay. But let's say we are in this world, and I tried to draw this the best I could. It's probably not going to be perfect. But, let's say something to do with the timing. Oops. Things are not going according to plan. So let's say with somehow with timing that player B ended up on team A and player A ended up on team B. Now, if this all occurs simultaneously, well, we know who would player A choose to go with. Well, automatically, both players would like to be on team A, right? Because team A is willing to pay both of them a higher wage. But let's just say, for the sake of this example, somehow with the timing, that team A was not team A was not able to sign player A in a certain year, and then a couple years went by, and they were able to sign people, or they had enough money to sign some additional players or something when player B was on the market. So it could be that, look, player A ended up on team B, and if player B ended up on team A, they could actually end up with the exact same wages, even though player A was of higher quality. Now, like I said, I tried to draw this perfect. It looks like this downward sloping line. I tried to get it so it was flat. But that could be the case. Now, if it all happened simultaneously, like I said, obviously, both players would choose to be on team A, and then team A would choose player A first instead of player B. But there could be a scenario because of timing, if one of these teams didn't have the money to sign a player in a given year, that maybe we do end up with people getting similar wages because a lower quality player ended up on a bigger market team. Okay, so I don't know. It's kind of interesting. It combines a lot of things here, right? We've combined differences in quality of the player, differences in the size of the teams. Right? So I don't know if we have I can kind of check here to see if we've got anybody watching online. If there's any questions, I don't think I have anyone really. Okay, well, all right. So also, just as a kind of a PSA maybe. So my other sections took an exam. They have 2 exams before their final. You guys only have 1. Judging on how they did relative to what happens in the past, and you guys have been doing a much better job of at least watching the recorded lectures. I highly suggest watching these. The ones that didn't, I can see the number of views I got, and it was only about half the students, and half the students did very poorly. And I can guess which half that maybe it was. So watching these lectures helps. I know these ones are a little bit, like we're kind of going off the deep end a little bit in that I usually like to have more discussion or covering these papers. But these papers really do give you a lot of good practice at interpreting coefficients, which will help you in your project. Like I said, I will have some questions like that on the exam as we've looked through a ton of papers at this point. Okay, so the next thing I want to go through, so I'm going to erase this. Now I want to try to incorporate, and we did quality differences, I think, in the lectures when we had discrimination. But let's assume I have 2 different types of players, right? So we're going to call this, well, I think because we went through examples, and I think that it's a viable question. Is there racial differences, right? If there's racial discrimination that goes on in certain leagues. So let's say we've got, there we go. I'm going to try to do this on one graph. We'll see how this works out. So we've got quantity of labor, wage. Let's assume, just for simplicity, that we have the supply curve for labor is the same for both. Actually, we can do kind of white and black. You can think about this as white, non-white, or however you want to think about it. But we'll keep it easy, kind of white-black, because we have historical examples of there being a pay difference between these 2 groups. So what if we have the exact same quality? So let's say that, right, the marginal wins per labor curve for white and black players is identical, right? Or we're looking at 2 players that are of identical quality, right? So that if that's the case, right, and the demand curve for labor is the marginal wins of labor times the marginal revenue per win. If this is the same between these 2 different players, white and black players, what if, right, we had large and small market teams? Okay. So we know that if we did have large and small market teams, so we'll say for the white players, we know that the demand for labor curve would just have to be lower for small markets as opposed to large markets. So we can think this is small, large market. Right, because a large market would have a higher marginal revenue per win, so the demand curve would be higher. Those larger markets could pay those white players a higher wage, right? So wage for the white players in a large market, wage for white players in small market. So without any discrimination, if we said that white and black players have the same marginal win per labor, it should be that the demand curve for white players is the exact same as the demand curve for black players in these different size markets, right? So and you can kind of imagine wages would be the same as well. But now let's assume, right, that we had discrimination occurring not in the small markets but in the large markets, right? Well, if we had only discrimination occurring in the large markets, and we'll assume it's employer or consumer discrimination, right? So employer or consumer discrimination means that there's a taste for discrimination, or if it's consumer discrimination, it pushed down the marginal revenue per wins. And so here, now we've got kind of this demand curve for, and we'll say it's against black players, in the large market with discrimination, right? So now what happens? Well, in those large markets, now the wages for black players is lower, right? So even with quality the same, right, large market teams, right, are less likely to employ someone if, right, a reduction in the quantity of labor and at lower wages, right? But if I'm only looking at small teams, there's no discrimination there, so they're willing to kind of pay these players the same amount, right? Now here what's interesting is, even with discrimination, if I'm a black player and I look at the choice between a small and large market team, I can still earn a higher wage on that large market team. It's well below what the value, right, of my labor is to that team. It's well below that, but it's still a higher wage than if I chose to be on that non-discriminating small market team, right? Now, if discrimination is large enough, and I drew this difference between small and large market, it's pretty big. Let's say I didn't draw it as big, or if there was a lot of discrimination, like let's say discrimination was huge in those large markets. Well, it could be, now I'm all the way down here, now the wage with discrimination is lower, and I choose to be on that small market team as a black player. But even with, if there's a pretty large gap between small and large market teams, this group that's being discriminated against could still choose to be on that team that's discriminating if they're the larger market team, right? What else did I want to kind of do here? Oh, so, okay, so we've got that. We're going to kind of redraw this for a second to do one more thing with discrimination. Like I said, because this is a recording, you can kind of pause that if you're trying to kind of jot that down. So let's say we have discrimination, but now I'm only going to focus on kind of I just want to focus on the group that's being discriminated against. I'm not really as concerned with the one that's not. So we've got supply curve for labor, wage, quantity of labor. Okay, so let's say I've got the demand from the large market, demand from small market. Here's there's discrimination in the large market. So large market, discrimination, right? So it looks like the wage still could be higher with discrimination. Right? But what if me as a player, I don't just care about money, right? So if they just cared about money, in order to supply this quality of labor hours or unit of labor hours, you would have to pay them this amount, right? But let's say, right, playing on a team that is discriminating against me causes me additional psychic costs. So I not only need this amount of wage, I need that plus whatever the amount is to cover my costs, right? To cover kind of these mental costs, right? Well, if that's the case, right, to get that same quantity of labor, I'm actually going to require a higher wage, right? So my supply curve might actually like maybe shift up or kind of backwards, right? It's at any quantity I require a higher wage, which means that at any given wage, I'm going to supply a lower amount of labor to be on that discriminating large market team. So it doesn't change the wage that the small market team would have to pay me, right? But now the kind of equilibrium here, if I'm supplying less labor and they're discriminating, looks like they're going to have to pay me a much higher wage to get the kind of same unit of labor they would have to get from this than if I was on a small market team. So how does this benefit small market teams? Well, now if these large market teams are discriminating, well, if the players are less willing to supply labor there and require higher wages, that team's going to have to pay higher wages to get the same quantity of labor that a small market team can pay much lower wages at, which is beneficial for the small market team, right? They're getting the same unit of labor hours out of the same quality of player, but at a much lower wage, right? So it's kind of interesting to think about if there were supply shift differences, because if I'm being discriminated against, my supply curve is going to be very different for that team than for the team that doesn't discriminate against me. Could have some interesting implications of that as well. So there's just a way of thinking about differences in small, large market. I didn't really do any differences in quality. I'll probably save that for tomorrow. Talk about some different combinations of what if we have different quality players with discrimination versus not, um, or with league minimums. We'll kind of play around with that as well. But today I wanted to focus on discrimination, large and small market, as well as what was the first one we went through? If we had quality differences in players with large and small market. I want to focus on this large small market thing today. Okay. So those are just some additional kind of problems. They should help you out with the homework assignment. So the homework assignment that's up there on Canvas right now isn't due until, like, I posted it Friday. It's due 2 weeks from that Friday. So you've still got quite a bit of time. It's mostly on discrimination, which we're not going to talk about for a little bit. I mean, outside of these reviews. So I would highly suggest start to working on that as soon as possible. So what we talked about last week and the week before is kind of fresh in your mind. That's the stuff that I'm really going to ask questions on. Discrimination and then paying athletes. Right? So tomorrow, today's stream kind of short. We just went over a little bit of some new papers. I'll get up the weekly reading today that I want you to have looked at for the weekly quiz that comes this week. So we'll go over a few more papers tomorrow and then work through some more examples on the board. If you have any questions, like what if this happened in the labor market? What if this kind of discrimination, or what if we had the combination of these two things? Please feel free to email me or come in live tomorrow at the same time, 1:30, and we can kind of go over those as well. Like I said, I'm kind of doing these on the fly. I have an idea about what I want to, like today I knew I want to do some large, small market differences and the combinations of different things we've talked about. But if you have specific ones, please reach out and let me know about what those are.